Hello students, welcome to the second video for the propositional logic chapter. Today we are going to discuss about truth values of a proposition. So what is a truth value? Every proposition. So we know there are two types of proposition, either simple or compound. So every proposition we know that it can take two values, either true or false. So these set of values are called truth values. So we denote the value true as 1 and value false as 0. Okay. So from here onwards we are going to use, instead of true we use 1 and instead of false we may use 0. Right. Okay. So what is the truth value of a proposition? I told you the truth value of a proposition, it can be either true or false. So for a definition we can define truth value. So truth value is defined as the truth or falsity of a proposition. Right? A proposition can give either true or false. Not both together, right? So either true or false. That value is called the truth value of that proposition. Okay. So in the case of a simple proposition, the truth value depends on that proposition only, right? So here we got some examples, like first one is 2 is greater than 1. So 2 is greater than 1. When we analyze this statement, we would say that it is a true. So the truth value of this simple proposition is true. So we got another example. The word mango comes before the word apple in Oxford Dictionary. So let me repeat. The word mango comes before the word apple in Oxford Dictionary. So when you consider these two words, mango and apple, of course the mango does not come before the word apple, because as per the alphabetic order, as it is a dictionary, it is of course in the alphabetic order. So that is a false. So here we considered two examples. One is 2 is greater than 1, and second one, the word mango comes before the word apple in Oxford Dictionary. The one is true and one is false. So in the case of a simple proposition, the truth value is, it depends on that truth value of that particular simple proposition only. Okay. Now we are going to find the truth value of compound proposition. The truth value of a compound proposition, it can be find out by checking the truth value of its components or propositions. That is, when we say compound proposition, it contains more than one proposition, right? So what is the truth value of a compound proposition? It depends on the truth values of individual propositions inside it. For example, you can see that October 21st, 2012 was Sunday, and Sunday is a holiday. So this is a compound proposition consisting of two propositions. October 21st, 2012 was Sunday, and Sunday is a holiday. So this contains two propositions. October 21st, 2012 was Sunday, that is a proposition, and another proposition is Sunday is a holiday. So we can say that this is a compound proposition. The truth value of this compound proposition depends on the truth values of the propositions. The first one, October 21st, 2012 was Sunday, and the truth values of the second proposition, Sunday is a holiday. Okay, when you check the calendar of 2012, you could see that October 21st, 2012 is was a Sunday, and of course globally Sunday is a holiday. So for this compound proposition, we can say this will give you true, right? So in the case of a compound proposition, the truth value of a compound proposition depends on the truth values of its of it if of its individual components. Like if the compound proposition contains more than one proposition, the truth value of the compound proposition depends on the truth values of the propositions inside it. Okay. Now we are going to see truth table. So truth table means, as you can see on the screen, the definition is given like it is a complete list of possible truth values of a given proposition, right? So it is a complete list of possible truth values of a given proposition. So here you can see that P is the proposition. P can have two values, either true or false. See, here we are using different type of notations. One is using only T and F, where T stands for true and F stands for, and one is using 1 and 0, where 1 stands for true and 0 stands for false, right? So truth table is a complete list of possible truth values of a given proposition. You might have observed that when there were only one proposition, there were two rows in that truth table. Suppose if we have two propositions, we could say that 2 raised to 2, there will be 4 values in the truth table. Similarly, suppose if we have 3 propositions, we could say the truth table may contain 2 raised to 3, 8 values. So here we are generalizing a formula for number of rows in a truth table. The number of rows of a truth table is n. So we can say 2 raised to n values will be there on the truth table. Okay. Okay, here you can see the truth table for a compound proposition which contains 2 propositions, and on the right hand side we have a compound proposition with 3 propositions. Look at the truth table for the compound proposition with 2 propositions and a compound proposition with 3 propositions. So P and Q are the two propositions inside the compound proposition. Then you can see that there are 4 set of possibilities. These are the 4 set of possible values for both P and Q. And similarly, we have 3 propositions, say P, Q, R. Then we can say there are 8 possible combination of P, Q and R values. Okay. We discussed about the logical connectives or logical operators last class. So now we are going to discuss about the truth table for these logical connectives. Let's start with the negation operator. So in the case of this negation operator, we know that the negation operator we use for inverse the truth value of a proposition. Suppose P is true, negation of P will be false. If P is 1, the negation of P will be 0. Like that it goes, right? So here on the screen you can see that P is having 2 values, 0 and 1, where 0 stands for false and 1 stands for true. So when P is 0, negation of P is 1, and P is 1, the negation of P is 0. Okay. Now we are going to see the truth table for the disjunctive operator, a disjunction or operator. We use the plus symbol to represent the or operator. So P and Q are the 2 propositions. We are going to find the truth values for P plus Q. So as there are 2 propositions inside this compound proposition P plus Q, P and Q, right? So P can have 0, 0 means false, and Q can also be 0. So P 0 and Q 0, P plus Q will be 0, and P 0, Q 1, that is P is false, Q is true. So in that case P plus Q is also true. Suppose if P is 1 and Q is 0, that means P plus Q is 1. And P plus Q, when P is Q, P and Q both are 1, then we can say P plus Q also 1. So we can formulate a general concept here. In the case of disjunction, so in the case of this disjunction or operator, we could say that it will return true in all the cases except when all the propositional values are 0. So what you can see here, it is whenever the propositional values are 0, then only it will return as 0. In all other cases it returns true. Okay. So when both P and Q are 0, then only it will return 0. In all other cases it will be 1 only or true only. Okay. Now we have the conjunction or conjunctive operator. So this is also called the AND operator. So here also we can see that P and Q are the two propositions. We are going to find the truth values for P dot Q. So here you can see that P and Q. So P and Q having 4 set of values. When P is 0, Q is 0, P dot Q or P and Q also will be 0. And P0, Q1 it will be 0. And P1, Q0 it will also be 0. When both P and Q are 1, then P dot Q will be 1. Right? So in the case of this conjunction, so we can summarize as it will return true only when all the values, all the input values or all the propositional values are 1 only. So it will return true only when all the propositional values are true. Okay. Now we are going to see the truth table for the conditional. So conditional operator, we call it is the implication. On the screen you can see we have P and Q are the two propositions. We are going to find the truth values for P implies Q. So when it is P implies Q, see P is 0 and Q is 0. P implies Q, it will return 1. When P is 0 and Q is 1, it will return 1. When P is 1 and Q is 0, it will return 0. And P1 and Q1, it will return 1. So we can summarize in the case of the conditional operator, it will return 1 in all the cases except when the first P implies Q, when P is 1, Q is 0, that will return 0. In all other cases, it is returning 1. If the first proposition is true and second is not true or second is false, we can say that it will return 0. In all other cases, it will be true. Okay. So there are some facts about the conditional operator. The conditional operator, it is also called implication. We join two propositions using if then. The conditional P implies Q is false when P is true and Q is false. And for all other input combination, the output is true. And please note that suppose if P implies Q, the first part P is called the antecedent and the second part Q is called the consequent. Okay. And now we are going to see some equivalent expressions. The conditional P implies Q, it can be expressed as P implies Q is equal to negation P plus Q. Right? So P implies Q is equal to negation P plus Q. What is the meaning of this? Actually P implies Q. If you find the truth values of P implies Q, it should be same as the truth values of negation P plus Q. Okay. We can verify that later. Okay. Now we are going to see the truth table for the biconditional. So biconditional, it is also called equivalence. So here you can see that in the case of the biconditional operator, it will return true only when, or we can say it will return true in all the cases where the propositional values are same. So here you can see that we have two propositions P and Q. It is returning 1 whenever P is 0 and Q is 0 and P is 1, Q is 1. When both P and Q values are same, it will return a true. In all other cases, it will be false. Now we are going to see some facts about the biconditional operator. In the case of the biconditional operator, it is false whenever the input values or the input combination is different, and it will return true whenever the input combinations are same. That is, when both are false, it will return true. When both are false, then also it will return true. Okay. When both are false, it will return true. When both are true, then also it will return true. That is, when the input combination is same, it will return true. And we can see some alternative representation for biconditional. See, P equivalence Q. P equivalence Q is equal to P dot Q plus negation P dot negation Q. We can validate this using the truth table. What is the meaning of that? P implies Q. The truth values of P implies Q is equal to the proposition P dot Q plus negation P plus and negation P dot negation Q. Okay. So we can validate this using the truth table that we will be discussing in the class. Okay.